Hey guys, I'm the coach of Team Aachen. Our team consists of our customer Stefan, the project lead Marco, that's me, the coach, and then there's my great developer team that consists of Smile, Simon, Leonard, Emir, Tanya and Fabian. And now I'll hand over to Leonard to introduce you in our problem.
So, if I would challenge anyone to perform heart surgery, the reaction would most likely look like this. But many medicine students have to face the task of performing surgery during their studies. However, teaching this is pretty difficult. Let me present you our solution to that. That's the AR microscope. Our challenge now is to develop an iPad app which enables the trainer to interact with the AR microscope, but first of all, displaying exactly the same video feed on the iPad as seen in the AR microscope. And now the trainer can use the Apple Pencil to draw annotations directly on the iPad, which are then also shown in the eyepiece of the student. This makes teaching so much easier because the trainer does not have to interrupt the student anymore. And also, the trainer can supervise multiple students by connecting multiple microscopes to the iPad. Let's get real quick here in the functional requirements, first of all. Obviously, we want to have support for the annotations and the video stream, but also the support for connecting up to 4 microscopes simultaneously. Next up, the non-functional requirements. In terms of performance, it's crucial to have a low latency, below 1 second, in order to achieve real-time communication between the student and the trainer. And last but not least, many trainers may not have much technical experience. That's why we have to have an easy-to-use interface, and we do this by limiting the amount of clicks needed to access a feature to a maximum of 2. Now, I would like to show you a short TV show that was recently aired that featured our product.
Have you ever tried to collaborate on the same microscope?
No!
Introducing the brand new AR microscope.
Wow!
Did you know that it was developed in cooperation between the RWTH Aachen and TU Munich?
No, I didn't. Excellent!
Right, now you can use your iPad to draw annotations using the Apple Pencil, which are then directly shown in the eyepiece of the student.
Nice!
And the best thing about it is that you can not just connect 1 microscope, but up to 4 microscopes at the same time.
Incredible!
But wait, there is more. With a simple gesture, you can even stream to a big TV, such as this one.
The future is already here.
So why stick with the old tech?
Pre-order our brand new AR microscope today.
And as a special guest, I would like to welcome the host, Tanya. Welcome on stage.
Hello everyone, and today we would like to show you our app in action in the real-world scenario. That's why I have invited an expert in this field. Welcome, Emir.
Hi everyone, I'm glad to be here. Thanks for having me, Tanya.
Let's take a look at Fabian over there performing a complex surgery right now.
As you can see, it's an extremely dangerous procedure, but thankfully we can keep an eye on him using our app, or even give him guidance if needed.
Oh, I guess he needs some assistance right now.
You're right, so why don't you take the iPad and the pen and draw a circle right around here?
Uh-huh.
Perfect.
But I guess he seems a bit lost a bit.
So why don't you take the marker then? Yeah. And mark this spot right here. Yes, exactly, that's right. Now he'll get it.
That's super. He's doing correctly now, but all the annotations are still there. Can we maybe delete them somehow?
But of course, why don't you just pick the eraser with the button? Exactly, and they're gone. But if you want them gone immediately, you can just press this single button in the corner and poof, they're gone.
Super! Now I don't need to worry anymore about Fabian making a mistake about everyone noticing him.
Exactly, and Fabian can focus solely on his surgery.
Thank you, Emir.
You're welcome.
And now I would like to hand over to Smile, who will give us a deeper look in the system.
Thank you, Tanya and Emir, for the lovely live demo. Now, for the next couple of minutes, Simon and I will guide you through our system design by introducing our components step by step. First, we'll start with our basic human operators, which are our trainer and trainee. As both share similar capabilities, such as performing procedures under a microscope, we want to generalize them to one class called the operator. Now, since our operators need something to actually work on, we introduce our most fundamental class called microscope, and a sample as well, since our sample, well, represents an object under our microscope. Next up, as already mentioned, our trainer has, can view multiple microscopes on his annotating device. And for that to represent, we want to add a video feed class. But right now we have a problem, which is we don't have anyone who could watch this. So, which is why we want to add spectators, like you guys, who could watch a live presentation or replay afterwards. That said, replay capabilities won't come out of the blue, which is why we want to add a video storage, which saves our annotations and videos for later on. Last but not least, we want to add our signature component to our system, which of course are the annotations. Our annotations are contained in a video feed and can only be drawn by a trainer on his annotating device. So this sums up our basic system design, but Simon will talk to you a bit more about it.
Thanks, Mal. Let's see how we can split up our model here. I'd say since the microscope is an integral part of our system, we should honor it with its very own subsystem. So we obviously need some cameras to get a video footage of our sample, as well as a visual presentation unit in order to see the video content itself. Another important aspect of our system are the annotations, and we definitely need something to create them. Let's just call it annotator. And since it's quite important to see what you draw while you're drawing, the annotator definitely must have its very own visual presentation unit as well. Now, we need to think of how we can combine both the annotations and the camera footage into the video feed. This is where I want to introduce the video processor subsystem. And as we can see in detail is that we have a video transcoder that merges the annotations and the camera footage, passes it on to the video provider, which then actually distributes the video feed to all interested parties. As you can see, we decided to put our video storage in this subsystem as well. Last but not least, we want to provide the video feed to our spectators, like you guys, as well. So we need some kind of presenter subsystem with its own visual presentation unit. To wrap it all up, let's connect all those subsystems together. So we have each visual presentation unit connected to the video provider, in addition to the camera and the annotation provider connected to the video transcoder as an input. Finally, I'd like to invite Fabian on stage to talk about the current status of the project.
Thank you, Simon. As you already saw in our live demo, we have finished most of the design and UI of our app. And the drawing tools are already working as well. But maybe the most impressive thing we have achieved so far is the implementation of both our streaming protocols, the video stream and the data stream, which will be used for annotations later on. This was actually a challenge because we had to build it on top of our existing code base. But there's still a lot to do. We are currently working on this actual transmission of the annotations and improving the latency of our video stream to our definition to real time. Completely missing features like optimized view for the spectators and a dedicated file format which stores annotation together with the video, and a video player which enables to toggle annotations on or off while watching this replay. That's all we have for now, and I will hand over to our customer, Stefan. Yes, thank you.
Well, thanks everybody for the nice work. I'm actually quite impressed on how far you've made it in this short time, especially I guess the video transmission has been a pain in the neck. But I'm really curious. So for now, we only have 4 of these microscopes. But let's assume that we have, I don't know, maybe 3 or 4 seminars in parallel. So we might have maybe 20 of these, each working with individual trainers. How well does this system actually scale? So how much can we put through a regular network? Because there's a lot of video transmission going on, and I guess there might be a bottleneck.
Well, we have, currently the app supports up to 4 streams in parallel. Of course, it very much depends on your network setup as well, because that's going to be the bottleneck. However, what we could do is, like, first of all, those cameras actually record in a much higher quality than we are transmitting. So you get a high resolution 6K footage from your recording, but on the iPad, the preview is much lower in resolution in order to reduce bandwidth. And of course, we can vary on this as well in the future. Let's say if we have 20 streams in the same network, then we can adapt and say, okay, we want to stream in an even lower resolution so that the trainer can still see something on the iPad, but is not hold back by some network bottleneck.
Perfect. Thank you very much.